Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss another problem in our binary search tree series. The problem name is Kth largest element in BST. So this problem is pretty similar to the previous problem, Kth smallest element, and this problem is Kth largest element. So let us understand the problem statement. So we are given the root node of a binary search tree and we are given an integer k. Now we want to return the kth largest element in that tree. K is 1 based indexing. So this problem is pretty similar to the previous problem. The previous problem was given the root of a binary search tree and an integer k. We wanted to find the kth smallest element in the tree. So let us take an example to understand this problem. Let us say we are given the root node of the binary search tree as node 35. Now the left child of node 35 is, let's say, node 25 and the right child is node 45. Now for node 25, let us say the left child is node 15 and the right child is node 30. Now for node 45, the left child is null and the right child is node 55. Now for node 15, the left child is null and the right child is null. For node 30, the left child is null and the right child is null. For node 55, the left child is node 50 and the right child is node 58. Now we are given k as 2. We want to find the second largest element in this binary search tree. So what is the first largest element in this binary search tree? So the first largest is node 58. Node 58 is the largest value present in this binary search tree. So what is the second largest? The second largest is node 55. So we are simply gonna return node 55 as our answer. So let us say we are given k as 5. Okay, so what will be the answer for this? So here node 58 is the largest node, node 55 is the second largest, then node 50 is the third largest, node 45 is the fourth largest, node 35 is the fifth largest. So we are simply gonna return node 35 as our answer. Okay, I hope the problem statement is clear to you guys. So let us understand how we can solve this problem. So let us take an example. Let us say we are given the root node of the binary search tree as node 33. The left child of node 33 is, let's say, node 23 and the right child is node 43. Now for node 23, the left child is node 13 and the right child is node 25. For node 43, the left child is, let's say, node 40 and the right child is node 46. Now the left child of node 46 is, let's say, node 44 and the right child is node 48. We want to find the fourth largest element in this binary search tree. So how can we do this? Pretty simple. We can do an in-order traversal of this binary search tree. So what is the in-order traversal of this binary search tree? So starting from the root node, the in-order traversal will be left subtree processing first, then the processing of the node, and then the processing of the right subtree. I have already explained you the in-order traversal in my binary tree series, so please look at that video once. Okay, so we are going to start from the root node. So initially we have an in-order array which is totally empty. Okay, now empty. So from the root node 33, is there any left subtree? Yes, the left subtree is node 23. So we'll reach on node 23. Now for node 23, is there any left subtree? Yes, the left subtree is node 13. So we'll reach at node 13. Now for node 13, is there any left subtree? No, there is no left subtree. So now we are going to process the node. So processing the node means adding the value of 13 in my in-order array. So let us add this 30. So 13. Now, is there any right subtree for node 13? There is no right subtree for node 13. So we simply gonna return. Now for node 23, we have processed the left subtree. Now we are gonna process the node. So we are gonna add this value of node 23 in my in-order array. So 23 will be added. Now, is there any right subtree for node 23? The right subtree for node 23 is node 25. So we'll reach at node 25. For node 25, is there any left subtree? There is no left subtree for node 25. So now we are going to process the node. So processing the node 25 will be added in our in-order array. Is there any right subtree for node 25? There is no right subtree for node 25. So we simply gonna return. So now for node 23, we have processed the left subtree, we have processed the node, and we have processed the right subtree. So we are again going to return. Now for node 33, we have processed the left subtree, Now we are going to process the node. So how we are going to process the node? We are going to add the value of 33 in my in order array. So now we are going to process the right subtree. So the right subtree of node 33 is node 43. So our recursion will reach at node 43. Now for node 43, is there any left subtree? Yes, the left subtree is node 40. So we'll reach at node 40. For node 40, is there any left subtree? There is no left subtree. So now we are going to process the node. So the node itself, 40 will be added in our in order array. So now, is there any right subtree for node 40? There is no right subtree for node 40. So we simply gonna return. Now for node 43, we have processed the left subtree. Now we are gonna process the node. So 43 will be added in our in order array. Okay. Now, is there any right subtree for node 43? So the right subtree for node 43 is node 46. So we'll reach at node 46. For node 46, is there any left subtree? The left subtree is node 44. So we'll reach at node 44. For node 44, is there any left subtree? There is no left subtree. So now we are gonna process the node. So 44 will be added in our in order array. Now, is there any right subtree for node 44? There is no right subtree for node 44. So we simply gonna return. Now for node 46, we have processed the node. We have processed the left subtree. Now we are gonna process the node. So 46 will be added in our in order array, right? Now, is there any right subtree for node 46? Yes, the right subtree of node 46 is node 48. So we'll reach at node 48. For node 48, is there any left subtree? There is no left subtree. So now we are gonna process the node. So processing the node, 48 will be added in our in order array, right? Is there any right subtree for node 48? There is no right subtree for node 48. So we simply gonna return. Now for node 46, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we are again going to return. For node 43, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we are again going to return. For node 33, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we are again going to return. Now in the end, we have our in order array ready. So in order array of binary search tree gives us a sorted array. So this is nothing but a sorted array, as you can clearly see, and we want to find the fourth largest. So we can iterate from the reverse direction, that is from backwards, and the fourth element is the fourth largest. So 43 will be our answer. So node 43 will be our final answer. Now talking about the time complexity of this approach, the time complexity of this approach is pretty clear. It is big O of n, where n is the number of nodes present in this binary search tree. We are not doing any external sorting. The sorting of this in order array is automatically because of our in order traversal. Talking about the space complexity of this approach is also big O of n, because we are creating an extra array space. Okay, so the space complexity is big O of n. Can we do something better? This approach is very good, very optimal, but can we do something better? Can we do something better in terms of this space complexity? Can we bring down the space complexity to constant? Yes, we can. If you remember the previous problem, we are going to use the same logic to solve this problem, but in this problem we are going to perform a reverse in order traversal. Now what is a reverse in order traversal? A reverse in order traversal is, we are firstly going to perform the right subtree first, then we are going to process the node, and after that we are going to process the left subtree. So in this manner we are going to get an in order array in descending order. Okay, so from that we can just find the constant k. So let's understand that. So let us say we are given the root node of the binary search tree as node 25. Now the left child of node 25, let's say node 15, and the right child is node 35. Now for node 15, the left child is, let's say, node 5, and the right child is node 20. Now for node 35, the left child is, let's say, null, and the right child is node 45. Now for node 45, the left child is, let's say, node 40, and the right child is node 48. We want to find the fifth largest element. So how can we do that? We can do a reverse in order traversal. So reverse in order is, process the right subtree first, okay, then process the node, and then process the left subtree. Okay, and that's it. So what we need to do, we need to firstly declare an answer variable. Answer variable is going to tell us the kth largest node. So initially it is set as null. So now we are going to start our processing from the root node, so node 25. So for node 25, is there any right subtree? Not the left subtree. We are performing a reverse in order traversal. So is there any right subtree? So for node 25, the right subtree is node 35. So for node 25, the right subtree is node 35. So our recursion will reach at node 35. Now for node 35, again, is there any right subtree? So for node 35, the right subtree is node 45. So we'll reach at node 45. Now for node 45 again, is there any right subtree? So the right subtree of node 45 is node 48. So our recursion will reach at node 48 now. Okay, for node 48, is there any right subtree? So for node 48, there is no right subtree. So now we are going to process the node. So how we are going to process the node? We are going to decrement the k by 1. So k decrementing by 1, it will become 4. Now since k is not equal to 0, so we are not going to do anything. Okay, the same approach that we have used in my previous problem. Okay, so is there any left subtree for node 48 now? So for node 48, there is no left subtree. So we're simply going to return. So now it will reach here. For node 45, we have processed the right subtree. Now we are going to process the node. So how we are going to do that? We are going to decrement k by 1. So it will become 3. Now k value is not 0. So we are not going to do anything. So now, is there any left subtree for node 45? So the left subtree of node 45 is nothing but node 40. Node 40. So our recursion will reach at node 40 now. Now for node 40, is there any right subtree? There is no right subtree. So now we are going to process the node. So processing the node, decrement k by 1. So it will become 2. Now, is there any left subtree of node 40? There is no left subtree of node 40. So we're simply going to return. Now for node 45, we have processed the right subtree, we have processed the node, we have processed the left subtree. So we can again return. So our recursion will reach here. Now for node 35, we have processed the right subtree. Now we are going to process the node. So how we are going to process the node? Decrement k by 1. So it will become 1. Fine. Now, is there any left subtree for node 35? There is no left subtree for node 35. So we're simply going to return because we are done with the right node and left. Now we'll reach here. For node 25, we have processed the entire right subtree. Now we are going to process the node. So processing the node, k value will be decreased by 1. So it will become 0. Okay, now the value of k has become 0. So what we are going to do? We are going to change our answer to the current node. So answer will become node 25. And whenever our k value will become 0, we are simply going to return from that, and we are simply going to come out of our recursive function call. So we are simply going to come from here, and that's it. Okay, talking about the time complexity of this approach, the time complexity of this approach is big O of k, where k is the value of integer given to us. In the worst case, k can go up to n, so it will be big O of n, where n is the number of nodes present in this binary search tree. Talking about the space complexity, the space complexity is constant because we are not creating any extra space. We are just using an in order traversal in reverse manner. There will be a space used in the recursion stack, but there will not be any auxiliary space created. Okay, so talking about the space complexity, it is constant if we are not considering recursive stack space. If we are considering recursive stack space, it will be big O of k. Fine. I hope the solution approach made sense to you guys. Now we are going to understand how we can implement the logic in the form of code. So let's do that as well. So as you can clearly see, I have already declared a function called Kth Smallest. I need to change this function to Kth Largest. Okay, so Kth Largest is taking the root node as an argument and an integer k. Now root node is nothing but an object of class tree node. A class tree node is having a constructor that is initializing the value of the node. The left and the right child of any node is by default set as null. Now what is the first thing that we need to do? First thing is to initialize an answer. So since we want to change this answer in our recursive calls, I'm going to declare this answer in the form of an array. So answer is equal to none, so that it will keep on updating. Okay, and never loses its originality. Okay, now after this I want to change k as well during my recursive call. So I'm making this k as a array. Okay, so k is equal to list of k. Now after this I need to call a recursive function. So let's name that recursive function as Kth Largest util. I need to pass this root, I need to pass the k, and then I need to pass the answer. Okay, now after from this function we are getting our answer in this answer. So return answer of 0 will be our final result. So let us now write this function Kth Largest util. It is taking the root node, the value of k, and the answer. So now what is the first condition? The first condition is if the root node is currently null. So if root is null, in that case we can simply return. There is nothing much to do here. Okay, now what is the second thing that we need to do? The second thing is process the right subtree first. So let's process the right subtree. So Kth Largest util root.right. Okay, and then pass k and then answer. Now after this we are going to process the node. So how we are going to do that? We are going to decrement the value of k by 1. So k of 0 minus equal to 1. Fine. Now if k of 0 is 0, in that case we need to change our answer as current node. So answer will be root. So how answer will not, answer of 0 will be root, okay, because this is an array. Now after this we need to make a call to its left subtree. So kth largest util root dot left and then k and then answer. Now from this we can just simply return. We can do a bit optimization to solve this. We can check here that if my k of 0 is 0, so in that case we can also return. We don't need to go for downwards more. If my k is 0, that means we have got our answer. That's it. That's all the code that we needed to do. Let us take a quick example to run my code. So let us say we are given the root node as node 25. The left child is nothing but node 15. The right child is nothing but node 35. Okay, now the left child of node 15 is node 5. Okay, now we want to find the third largest element. So let's call this function kth largest. So if we are simply going to call this function, it is going to give me a tree node object. So let me show you what do I mean by this. So it is giving us a tree node object because we are returning the node itself. Now if we want to check the value, I need to just do dot value. Dot value is the attribute. So let's give this a function run. So now 15 is the third largest value. So let's verify. 35 is the first largest, 25 is the second largest, and 15 is the third largest. So 15 is the correct output. I hope the problem statement, the solution approach, and the code made sense to you guys. If you guys still have any queries regarding this problem, please drop your concern in the comment section and I will be more than happy to help you there. Regarding the series, I will be uploading more of the questions in the upcoming week. So keep following us. Until then, keep smiling and keep coding. Thank you.